of you maybe started this already, but this is a really essential skill from Algebra 1 that you are going to be using throughout geometry. And it's just solving equations. So in these first two, we kind of have your basic two-step equation. Again, when we're solving, we're trying to get the variable by itself. What's our first step in getting that variable by itself? Name? Parker. Parker, what's our first step?
Adding 17.
Good. Add 17 to both sides. Again, how I like to think, if you're unsure of which one to move, pick the number that's furthest from the variable. 17 is furthest from the variable. That's the one we're moving over. And 60 plus 17 is 77. We still have to get that variable by itself. What's our next step? Okay, what's our next step?
77 divided by 7.
Perfect. Divide both sides by 7. And when we do so, 77 divided by 7 is what? Right? 11. Perfect. 10. That's what we're perfect. Same kind of thing with Z. We need to get Z by itself. It's a little bit of a trickier one. What do we need to move over first to get Z by itself? Ross?
Move the 6 to the 10 multiplier.
If we look, which one is a further distance from that Z? 6 or the 5?
The 5.
The 5. So which one do we want to move over first?
The 5 first.
Good. How are we going to move it over?
By subtracting it.
That is a tricky one. And 10 minus 5 is 5. Now, what do we need to do with that 6 to get Z by itself? Good. Multiply by 6. Fine, we get Z is equal to 5 times 6 is 30. Questions over that? Okay. Now we take a look at C. What's a little bit different about C than those first two we did together? Can we? Yeah, there's variables on both sides. There's more than one X. So when this happens, we have to take one of those X's and move it over to be with the other. Some of you like to move everything to the left. Totally fine. What I like to do, because I like to keep my X values positive, because I think it makes it a little easier to solve, I pick the smallest X, and that's the one I do. So sometimes it's things are on the right, sometimes things are on the left. You do what works for you. Which one's smaller, the 8X or the 5X? 5X, that's the one I'm moving over. How are we going to move that 5X over? Very good, we're going to make it a negative. We're going to subtract it. So we're going to subtract 5X on both sides. Cancels out. 8 minus 5, 3X plus 12 equals negative 9. Now we're back to what we did in that first problem. Because this is your basic two-step equation. Okay? And again, to get X by itself, move that 12 over first, do the opposite, subtract it. Negative 9 minus 12. What do we get? Good. And then again, we go ahead, have to get that X by itself, divide by 3. And when we do so, negative 21 divided by 3 is negative 7. Those are the type of problems you're going to see a lot of that we're going to solve. Binomial equals a binomial. And geometry. Important to know how many those. Okay. Questions over that? Oh. If we take a look at D, again, we have more than one X. We have more than just one number. What do we need to do in D before we do anything else? MJ. I think you're on our track. Yeah, very good. We're going to combine our like terms. I knew it to miss. So we're going to combine everything that has an X together, And we're going to combine everything that has a number with the rest together. Here's the thing. You have to be very, very, very careful. I see this a lot. We just get so used to when we're solving equations doing the opposite. Okay? But if you notice, these are on the same side of the equation, so you keep them the same sign. We don't need to change the signs of anything because they're all on the same side. Okay? I see sometimes we're adding the 8, so when I combine it, I need to subtract the 8. They're on the same side, so you're just keeping that 8 positive. Okay? Just be careful on these. So we combine it, 6x plus 8x, 14x. Okay? 20 minus 10 is just 10. Just have to be really careful with this. Same side, keep the signs the same. Opposite sides, change the signs. Without stuff. And then it's back to that two-step equation from the beginning. Just move the 10 over. 50 minus 10 is 140. And divide by 14, just like we did in the beginning. And 140 divided by 14 is questions over now. If we take a look, I can't remember what I did. Let's do what I did. Now we skip one of these. I like this one. Okay. Again, what do we have to do before we do anything else in this problem when we're solving?
Gotta combine the like terms.
Very good. Gotta combine those like terms. So we can combine anything that has an x together that's on the same side, and combine anything that doesn't have an x on the same side together. Okay, when we do that, keep the signs the same. 7x minus 9x is what? 2. Perfect. And then 13 minus 2 is 11. Why did I think that? And then again, your two-step equation. Just move the 11 over. Divide by negative 2. And negative 2 divided by negative 2 is positive 1. Very good. I think we skipped one of these. Do this. Okay. Sorry. We'll go jump to G. In G, before we do anything again, what must we do?
Combine like terms.
Good. Combine our like terms. Combine our like terms. And again, we're only combining like terms that are on the same side. So we combine 6 and 3 together, we get 9. And we combine 7 and negative 1 together, that gives us 6. We combine our like terms. What's the problem here? We'll have x's on the other side. So whatever way works for you. If you want to move the 12 over, that's fine. I like moving the little one over just to keep things positive. How are we going to move that 9x over? Subtract it. Very good. It's positive to move it over. We're going to make it negative. So we get 6 is equal to 12x minus 9x is 3x minus 15. Move the 15 over. And those nice little two-step equations. We get 21. Divide by 3. then with H, we have a lot going on in H, but that is okay. Again, our first step before we do anything and move things over. What must we do? Always combine those like terms if you can before you start moving things over. So I'm going to combine these terms together. Combine these together. And we also have terms over here to combine. So I'm going to combine those terms together. Okay? And whatever's on the left you combine, whatever's on the right you combine. Keep them separate still because you have that equal sign. So we're just going to combine the 8x and the 3x together. 8x plus 3x is 11x. And you combine the negative 7 and the positive 3 to get negative. And then combine your 6x and your 2x to get 8x. And then drop down that 32. Sometimes you have to combine like terms on both sides. And then solve. What's our first step in solving this one? What are we going to do? We're going to solve. Sebastian, what are we going to do? Yeah, remove that 8x over. (3x minus 4 equals 32. And keep solving. Trenton, what's our next step? 4x, perfect. (3x is equal to 36. And our last step, Celeste, what's our last step? Perfect. So bye-bye. And 36 divided by 3 is 12. Questions? Alright, if we take a look at I, this one's a little bit different. So you have fraction equaling a fraction. Alright, this is what we call a proportion. We'll deal with these later down the road and apply them to geometry concepts, but it's always good to review how to solve this. Does anyone remember how you solve this? What? So we can multiply 30 over 1. You can. That is going away. You are not wrong. There's a specific way I'm looking for that's going to help us with the next one. So if you multiply both sides by 30, totally. There's a specific method.
Cross multiply?
Cross multiply, yes. And again, why I'm using cross multiplication on this one, it's going to help us with the next one. But you can, as Celeste said, just multiply both sides by 30 and you're going to get the right answer. But we're going to cross multiply. When you cross multiply, you just start at the top, go diagonal and multiply to the bottom. Do the same thing. Start at the bottom of the fraction, multiply across to the top. Okay? So when we do that, x times 5 is what? 5x. And then you just bring the equal sign. And then you do the same thing with the bottom and the top of the other. 30 times 2 is 60. And then solve. To solve this, what do we have to do?
You have to divide the 5.
We're just going to divide by 5. Just divide both sides by 5. And 60 divided by 5 is what? Oh. So you like to think it's cross multiply divide. Is the method you use. Questions over that? Okay. If we take a look at J, again we have a fraction equaling a fraction. So what method are we going to do to solve this? Cross multiply, just like we did on the other one. It's a little bit different than the previous one because we're adding things to the x. When this happens, whenever I have a binomial with an x, I know I have to cross multiply. Right away, I go like that. Right away. It helps you with my cross multiplication. So the process is still the same. Top diagonal to the bottom. Bottom diagonal to the top. You just have to be very careful. When we multiply 3x plus 1 together and the 3, That's why I put the parentheses. Because you're multiplying this whole entire thing by 3. So by putting that parentheses, you're sending that right. And that equals these two being multiplied together. 2 times 4 is. So whenever you have that binomial, you just rewrite it with parentheses. Whatever the other number is, you write it in front. What do we have to do with this 3 when we start solving this? I don't know what that's called. Stated? No, I don't know. Sorry. I don't remember what's called. Do you know what like operation we have to do with it? Good. We have to multiply everything inside the parentheses by 3. What's a fancy word for that? Distributing. Good. We have to distribute that 3. And when you distribute, all you're doing is multiply. Okay. So we multiply. 3 times 3 is 9. And 3 times 1 is 3. And that's family 8. And now it's just your basic two-set structure. Okay. Just like we did on the other ones, move that 3 over. 8 minus 3 is 5. Divide by 9, and no, this is not wrong. Can 9 divide into 5 evenly? No. So what do the directions say do? Simplest fraction form. Good. So can 5 over 9 simplify? Nope. So just leave it like that. That's our answer, 5 over 9. Sometimes in geometry it's going to tell you to leave it in the exact form, simplest fraction form. Sometimes it's going to tell you to round. And it's going to tell you to round to a specific thing. So just make sure you're paying attention to the directions, because you'll lose a little bit of points if you don't follow them. Okay. Questions over there? No? Okay. Last two pretty quick. Here, again, we have to get x by itself. What are we going to do to get x by itself in this one? What? 10. And 40 minus 10 is 36. Is x by itself? Oh, so it's an exponent, right? Trenton, what do we have to do to get rid of that exponent? Good. We have to square root both sides, because we are squaring the x. The opposite of squaring is to square root. And what you do to the one side, you do to the other. That makes the x go away, and the square root of 36 is 6. Okay. Sometimes I see square root of 36 is 6, and then we still leave the radical. Okay? It's a perfect square, so that radical is going to go away, you just leave it as 6. If your calculator doesn't have the radical around it, you're not going to put the radical around it. Questions over there? Same kind of thing with this last one. Again, to get x by itself, what do we have to do with that 14? Subtract it. Just like any old other equation. 78 minus 14 is 64. And again, just like we did on the last one, what do we have to do to get rid of that square? Square root. So we square root. We get 8. Again, there's a perfect square. I want to get rid of the whole thing. There's no little street. So there's no more radical. Questions over that? The rest of the time is yours.